Hello everyone and welcome to our online symposium. My name is Denise Stewart and I'm General Manager of Operations at Studiosity. I'd like to begin by acknowledging and paying my respects to all the traditional custodians of the land on which we're gathered today, individually and digitally. I'd like to pay my respects to the elders, past, present and emerging. I'm really delighted to facilitate this session today with Dr. Stephen Wan, research scientist at CSIRO's Data61. And today, Stephen is going to talk to us about the role of artificial intelligence in writing feedback applications. Now, for those who aren't familiar with Data61, they are the data-driven research arm of the CSIRO, or Commonwealth Scientific and Industrial Research Organization. I prefer CSIRO, less of a mouthful. Now, one of their key focus areas is artificial intelligence and machine learning. And we all benefit from the right level of AI in our lives, whether it's a quick spell check before we send out an email, using Siri or Alexa as an assistant, or indeed a smartwatch that tells us we've been sitting at our desks too long and we need to get up. Studiosity and Data61 have formed a 5-year partnership, and we're committed to investing $1 million plus to explore hand in hand with Data61 how we can further pursue a truly exceptional student experience through combining our sophisticated and rigorous human support that we have today with artificial intelligence. So it is my absolute pleasure to hand over to Stephen and his presentation on the role of AI in writing feedback applications. If you have any questions, please add them throughout the presentation via the Q&A button you'll find at the bottom of your Zoom screen, and we'll address them at the Q&A session at the end. So over to you, Stephen.
Thanks, Denise, and good morning, everyone. I'm a computational linguistics and a natural language processing researcher at the CSIRO at Data61, as Denise said, and I lead a team of researchers and engineers focusing on language technologies. And I'd like to thank my colleagues, you can see them on the screen there, who also contributed to this work. And we're very excited to be working with Studiosity on this project. You know, we're seeing great leaps being made in artificial intelligence and natural language processing, leading to all sorts of wonderful new applications, such as online tools that provide automatic grammatical error correction, for example. And as a result, one might wonder, what role will these technologies play in the context of perhaps a writing feedback application? And I want to argue that there are two opportunities here. The first is that we have a great chance to capitalize on recent AI advances, particularly if this is moderated by learnings from prior explorations about writing feedback applications. And secondly, there's an opportunity to help the tutor to excel in providing writing feedback to students online through a tutor-in-the-loop productivity tool, if this activity is guided by good design methodology. So whenever somebody asks me, how can technology help? I like to think of a related question. Who are we trying to help? And the two obvious candidates are, of course, the students and the online tutor, who is, in this case, providing writing feedback. The key premise here is that this is an education scenario. So the goal is to learn to write better, not to automatically correct all the errors in a text. And if you've ever proofread a student's writing, you'll know how hard it is to walk that line of simply correcting text on their behalf and versus presenting the feedback in a format that they can use to take the next steps to improve their own writing. So what are some of the options for AI to help in this space? Are we talking about an autonomous tutor that does all the writing feedback for us? Or are we talking about productivity tools to help tutors reach out to more students, perhaps to help tutors invent new ways of working to deliver a higher quality service to students? It would certainly seem that in our post-COVID world, online delivery of these services is going to be a key strategy. Productivity tools can help as we race to adapt to this current situation. Recent advances in artificial intelligence and natural language processing are simply quite astounding. But as I said, I'm going to argue that remembering and learning from prior research prior to the current AI boom is going to be crucial in developing writing feedback technology for today. The published literature suggests that in the immediate future, the complete automation of a tutoring service for writing feedback is perhaps unlikely. There's just so much, as we shall see, that is unexplored or unfinished, even when it comes to handling basic grammatical errors, let alone more complex writing phenomena. So I'll argue that our goal should be a productivity tool for the tutor, a tutor-in-the-loop application of artificial intelligence. So for this tutor-in-the-loop scenario, where the tutor might use a productivity tool powered by some AI to help to perform a writing feedback task, we need to consider some key questions that will have a bearing on the impact of such a productivity tool. For example, we could ask, what's the right scope for the tool and for the AI? What sort of problems should it try and tackle? We know that AI often requires lots of data to develop appropriate models. So what should we look for in an appropriate data set? How can we avoid biases in our data that are going to be captured in our models, which will then reduce the impact of any productivity tool that we produce? And finally, with all the different advances in artificial intelligence and natural language processing going on at present, how do we decide which of these technologies to use? Fortunately, we have a wealth of published literature that can answer these questions. The place to start, though, I would say, is with our user, our tutor. It's important to examine the workflow that somebody is going to follow when providing writing feedback. The tutor first has to read the draft and understand what the student is trying to achieve, particularly if the draft isn't quite there yet, mark some of the errors to highlight problems with a view to summarize these errors in some high-level feedback to the student. We can take a look at an example from Studiosity. This is a PDF as the student might see it. And here I'm showing some of the first few pages of the PDF that includes some of the high-level feedback. And this particular feedback, piece of feedback that I'm showing on the screen is about a missing comma, in this case, after an introductory phrase. So the intention is that with this feedback, the student has to go away and think about this kind of construction in general. In the rest of the PDF, there's the student's writing, and there are comments from the tutor that are interleaved throughout. And I've highlighted a case where the tutor shows a specific instance of that error that we saw on the previous screen, showing where the comma is indeed missing after the introductory phrase. Note that the tutors don't mark every single error because it's up to the student to learn to correct the errors for themselves. But the feedback in the beginning should cover all the key elements that the tutor feels that the student is capable of improving upon. So by now, I hope you get a feel for the kind of feedback that the tutor must prepare. There's a high-level summary, and then there are some specific examples. So if we revisit our workflow again, we can be more explicit about these steps, adding an extra one in the middle there to identify the frequently occurring mistakes. Without this, we can't really abstract away from the individual errors to form some kind of higher level feedback. So where can technology help? Well, to help with identifying those frequently occurring mistakes, maybe we can surface them in some form to the tutor. And this puts us on a path where we want to consider some kind of automation to handle grammatical errors. So what's in scope for such a mechanism? Well, Claudia Leacock is one of the key computational linguists who's worked on this topic since the early 2000s. And she's led a publication of a survey on this precise topic in 2014. In fact, she's now at Grammarly. And Leacock and colleagues defined the scope of their influential survey in 2014 as including grammatical mistakes, but also errors in language usage, such as the selection of a word, and errors that are not simply due to hitting the wrong key. So those mechanical errors. So when I talk about grammatical errors in this talk, I will be using this broad definition that Leacock and colleagues established. So the survey notes that methods in natural language processing are advanced enough, even in 2014, to detect many of these errors. And this can be useful when learning to improve writing. And that's really quite promising. The survey also goes on to say that, well, the performance of the grammatical error handling tool will depend, though, on the type of error. And further into the survey, Leacock and colleagues also issue a warning, and they recall prior applied work in the field, noticing that artificial intelligence in the past has failed to deliver on the promise of a fully automated solution, such as the fully fledged conversational agent. And this is a cautionary tale that must ground us when we consider the possibilities with current technology. It's not all bad news, though. Leacock, after all, is working at Grammarly and has been since 2016. Two other key researchers in the field, Bryant and Ng, also analyzed the state of research in 2015, and they concluded that systems for automatically correcting grammatical errors, they seem to vary about as much as human editors do. So perhaps we're reaching the ceiling of the limit where automatic tools can head. And this suggests that, or they suggest that this kind of technology is thus ready to trial in the real world and outside of an academic research setting. Many would say that such technologies are viable today. For example, we've seen the rise of Grammarly in recent years, and there are increasingly more products coming onto the market. Here are a few on the screen that do automatic grammatical error correction. There's ProWriting Aid, Language Tool, and of course, Grammarly. And these are really wonderful products to help with proofreading, but they focus on editing and not writing feedback. So what exactly has changed, given that we're seeing all these products at the moment in the market? What has changed since Leacock and colleagues wrote that survey? Does that warning still hold true for writing feedback? Have there been new advances that are game-changing? And how does this influence the way we tackle the development of a productivity tool in this space today? Let's dive into the technology a little, placing it in its historical context, and we shall see that there are many opportunities that we can explore, but we should of course be mindful of the limitations of prior work so that we can design a solution with these limitations in mind. One of the key natural language processing areas that boomed in the 90s and since has been machine translation. And this field has inspired many of the current solutions to handling grammatical errors today. In machine translation, part of the boom was due to the creation of benchmark data sets. And in these data sets, you have a set of sentences, thousands of them. For each sentence, this is paired with one or more sample translations. And the artificial intelligence, the machine learning, has to learn how to transform the sentence into the sample translation. What we do then is we evaluate how well our algorithm performs by looking at its ability to mimic the creation of these sample translations. In the 2000s, natural language processing researchers explored different ways to capitalize on the richness of online text. Data, it seemed at the time, was everything. And if you could throw more data at a machine learning problem, it seemed like there was no end to the incremental improvements that you could get. A famous example of this is Google's Web 1T 5-gram data corpus in 2006. And this data set gives statistics of word sequences of up to 5 words in length, where these statistics are drawn from web text as a proxy for reasonable language use. These language models are fantastic. They can help us to estimate the probability of a sequence of words, and it can tell us which sequences of words are likely and which ones aren't. So you can use the language model, for example, to generate a probability for the translation candidates in a translation system so that you weed out the bad translation options. So to just make that concrete, imagine you have a translation system that gives you 2 candidate translations. You can use the language model to assign a probability to each one, and then use this to pick the correct translation or the most likely translation. Let's take a little bit of a closer look at why machine translation has been such an influence on grammatical error correction. It's not a bad approach, if you think about it, to think of grammatical error handling as being similar to machine translation. For every word in the system, the system has to decide whether to transform it or not. And depending on the algorithm that we use, some amount of context is pulled into this method to guide the transformation. So on the screen here, you can see there's an English sentence and we want to transform it into a German sentence. And at the word at position 3, if I'm looking to translate the verb sits or the infinitive to sit, the system might know that the corresponding infinitive verb in German is sitzen. Using the context of the 2 preceding words, die Katze, this might tell me, or it might tell the system, that the most probable version of the infinitive sitzen is sits, or which happens to be the correct conjugation of the verb in German. That is, my language model is telling me that those 3 words in sequence, die Katze sitzt, is more probable than any other alternative that the translation system might be considering at the time. And so the way that these machine learning algorithms work for translation is that they see thousands upon thousands of these pairings of sentences with their sample translations, and they simply memorize which words in English map to a corresponding word in German and under which contexts these mappings are valid. We can use the translation tools in a slightly different context. Here, we're using it to transform an input sentence that is grammatically incorrect to transform it into a corrected version. And again, using the same algorithms, we do this word by word. Here, in this case, the English sentence has a subject-verb error, and the word at position 3 is wrong. We want to transform sit into sits at position 3. And since we're using the translation algorithms, we can also exploit the context of the 2 preceding words, and the language model can tell us that the 3 words, the cat sits, is more probable than the three words, the cat sit. And if you compute these probabilities using large data sets for English, which happen to be at our disposal, to create these language models, and if you use the software libraries for machine translation that have been continuously developed and refined for decades, you quickly end up with potentially a viable solution to grammatical error correction. You might recall in the previous slide that the shift to data-driven methods and data-hungry approaches for translation, these went hand in hand with the availability of data. So for grammatical error correction, where will all this data come from? Well, in the last 2 decades, there has been a community within computational linguistics that has focused on building educational systems. And recognizing that there's a relationship between machine translation and grammatical error correction, over the last 10 years, this community has been preparing a number of data sets that capture this before and after transformation, pairing an incorrect sentence with a corrected one. So where do all these examples come from? Well, typically, they're either from publication venues for scientific writing, so either a conference or a publisher, where the corrections are made by copy editors, or else they come from English learning centers at universities. Often these centers have services that are designed for students for whom English is a second language, ESL students. And for these data sets, writing from the English ESL student forms a key part of the data. So in this case, the corrections are made by educators at the center or linguists, or freelance editors. Note that the most recent of these benchmark datasets for grammatical error correction was created in 2019, and it also looks at writing from ESL students. So what we have now is, instead of sample translation, we've got as a research community a rich data set of sample corrections. And this effort in building the benchmark data sets, this has been instrumental in accelerating the development of tools for automatic error correction. Adopting a translation-based strategy to handle grammatical errors means that we have to look at the situation where the system automatically corrects the errors, transforms it from the incorrect sentence to the corrected one. And this approach is great. It's very good, but it's not without its limitations. A key problem is this notion of a sample correction for the training set. It's hard to come up with a definitive correction independent of context. In my earlier example of the cat sits on the mat, there was, of course, another alternative correction, and that is the cats, plural, sit on the mat. When there are multiple corrections, independent of context, how is the automatic system to decide which is the most appropriate? And this introduces all kinds of methodological issues with adopting machine translation approaches for grammatical error correction. And so as a result, some researchers have argued that maybe we shouldn't look at automatic correction, maybe we should look just at error detection as a better target. So for this then, the machine should help us with a different problem, grammatical error detection. And this might have three parts. The first is determining that the sentence has a grammatical error. The second is determining which words are affected by that error. And the third is to specify the type of error. And if you think about it, this is potentially closer to what we need for writing feedback in any case. If we're to look at grammatical error detection, then we need appropriate data. And this brings us to the second key limitation in creating benchmark data to date. And that is in choosing an appropriate typology for the error types. For English, Leacock and colleagues write that the most frequent error is the misuse of commas. And they also write that punctuation errors are severely underexplored in the literature. And that problem still exists today. On the right, I've compared the error types from the most recent benchmark data set in 2019 to some of the error types that Studiosity uses. You can see that the Studiosity error types are more fine-grained than the academic data set. And the academic data set just lumps all the punctuation errors together into one category. So what does this mean for the student or for the tutor? Well, if we were to use the 2019 data set from the academic data set to build a grammatical error detection system, we might determine that there was an error in the sentence, and the system might work out which part of the sentence is the problem. But all it can then do is say, there is an error here and it's related to punctuation. And doing so, just saying that it's a punctuation error might not be so helpful. If you consider the earlier examples of writing feedback, the tutor was pointing out a specific kind of problem to do with the comma and the fact that it was something to do with introductory phrases. So the key thing to learn here is that the granularity of the grammatical error types that we need to have in the data set, these need to be appropriate for our writing feedback application. Finally, many researchers have commented on the fact that many of the academic data sets focus heavily on ESL writing. 4 out of the 6 benchmark data sets had a focus on ESL writing, including the 2019 data set. And this is probably due to the availability of this kind of data and the strong links that the computational linguistics research community have with organizations that run English testing facilities. But needless to say, if you're providing a writing feedback service, this should cater to all kinds of students, not just the ESL students. If your data set only represents ESL writing, you introduce a bias in your data error, in your grammatical error detection system, and that's going to affect utility. So we need to make sure that our training data is representative of the student population that we intend to cater to. Let me change gears for a moment and talk about a recent trend in natural language processing in general, not just technology from grammatical error handling. I mentioned before, language models are great. They can help weed out bad translations, and in grammatical error handling, these can be used to detect problems with a sentence and to also weed out less appropriate corrections. Neural network research has transformed the way that we do language modeling today, and this advance is as recent as 2018. And these new models are really a game changer. One of the latest models, affectionately called BERT, is based on masses of text that you find in Google Books and Wikipedia. So these new language models, they appear to be very general, helping with a range of complex tasks that would otherwise require some kind of reasoning about semantics. For example, they've been shown to help with the case where you need to determine if two similar sentences are paraphrases of each other. Or in other cases, they can help with finding answers to questions. They're also used to assign a classification label to a text. So it's really quite remarkable what recent advances in neural networks, these neural network approaches can do for natural language processing and what they can learn. And indeed, researchers seem to be racing against each other to explore all the benefits of these new language models from neural networks and applying them to new applications. So while these models appear to be very useful, they do reflect the language that was used to create the model in the first place, that underlying data. Specifically, if we're going to start with Google Books or Wikipedia, this means that the language model will capture correct English usage. And this was what was intended actually in the first place. But in our case, it'll be interesting to see how these models work when the underlying text is inherently different to Google Books or Wikipedia, when the underlying text, in our case for writing feedback, contains problems, may violate grammatical rules and spelling rules. So we need to be open-minded. While there's a lot of promise in these new AI methods, we may need to combine them with well-understood older methods that explicitly model incorrect language. So how does all of this help the writing feedback tutor? Coming back to some of the earlier questions, I would argue that designing productivity tools for writing feedback should be done acknowledging the limitations of the earlier work to identify the advantages of current advances in AI. From a technology point of view then, such a tool, a productivity tool, might focus on grammatical error detection and not grammatical error correction. And certainly we're a long way away from full automation of a writing feedback tutor. We saw the need to make our data more appropriate for the task, or the resulting tool will have biases built into it. So this means, for example, that the data has the right kind of metadata labeling that we require for the task of helping somebody to learn how to improve their writing. The data set also has to be representative of the target student base. And finally, we saw that different methods have pros and cons. A key question will be how we combine these different methods to capitalize on the strengths of each of the different approaches. And so we saw that we need to strike a balance between approaches that model correct language use, perhaps balance this out with approaches that are explicitly modeling grammar violations and spelling violations. You know, if we are successful, a grammatical error handling tool might remove an essential but mundane and time-consuming task from the tutor's workflow. And this is, of course, hopefully going to save the tutor some time. But it raises interesting questions. How do you present the results of this automation to the tutor? And this is where we need AI research to go hand in hand with user-centered design, where user-centered design can identify the needs of both the users and key stakeholders to influence the design of the productivity tool so that, for example, it is something the tutor can easily incorporate into his or her workflow. Just think about what it would be like if the system just automatically pointed out all the errors in the text on the screen for the tutor. Doing so could be simply overwhelming and perhaps counterproductive. Potentially, the benefit might be to aggregate statistics about the error types in some kind of diagnostic tool that describes the student's current writing and perhaps some of their past writing. And this might make the results of the automation easier to digest, allowing for the tutor to spend more energy in identifying the right kind of feedback to then pass back to the student and to decide how to present this to the student. With this kind of tool, maybe the tutor has more flexibility to determine the most appropriate kind of feedback, developmentally appropriate feedback for the student, for example. An example of this might be that they might want to then moderate feedback on a complex writing phenomenon, such as argument structure, if the student still seems to be struggling with more basic writing concepts, such as subject-verb agreements. So the idea is that the diagnostic tool can highlight where it is that the student is having difficulty and at what level the student might be. What about the roadmap beyond grammatical error correction and grammatical error detection? Well, of course, it's hard to say, but I think the opportunities are wide open. For example, the aggregated statistics might enable a longitudinal view showing how the student is progressing on different writing concepts, showing their progress over time on particular error types. So we might see that they've mastered, for example, articles and determiners. They're no longer having a problem with that, but they're still struggling a little bit with punctuation and commas. Further down the field, maybe we can have a look at incorporating more complex tasks that are also time-consuming for the tutor, such as looking at style recommendations or checking verb tense consistency. So to conclude, if we heed the warnings and learn from prior research, instead of blindly applying the latest and fanciest AI method, and if we adopt a user-centered design to guide us in the way that we develop the AI technology, then I believe we stand a good chance of developing a productivity tool that can focus on the mundane, time-consuming tasks of detecting all the errors. And then we stand a good chance of freeing up time and capacity of the tutor to focus on being a teacher so that they decide how to convey the learning objectives to the students. And we can also stand a good chance of then having a positive impact on helping to improve the quality of the service or perhaps the time to deliver a high quality service. Ultimately, all of this is to maximize the human touch of providing an online writing feedback service. Thank you.
Well, thank you very much, Stephen, for that fascinating talk around AI and writing feedback. Absolutely, absolutely. There's another question that's come through here. How Studiosity is going to use the combination of AI error detection with our subject specialists so we can focus on the feedback and increase student confidence in their writing. And for me, I will start answering that one, if that's okay. For all of us, it's all about the student having the right experience in the moment and across time as well. And that's always going to be human-centered, always. There is no intention here of ever replacing the human with AI because the student doesn't learn in the same way. It's about detection, not correction. It's about feedback. It's about learning. So the way that we're going to do this is we're going to take those AI tools and we're going to use them to better inform the specialist. So with the time that that specialist has, they are able to go directly to the issue that is most important for that particular student in that particular interaction. It will mean the specialist has more time to focus on areas that are more subtle and nuanced, and certainly areas that AI is not able to help us with at the moment. So that's how we're going to approach it, and we will approach it for every single interaction. We expect to deliver 500,000 interactions with students this year, and every single one of those is vitally important to that individual student. So always human, AI just boosting the ability of the specialist. Do you think students will prefer learning from machines or from humans? And when do we think we'll get to a point where we just can't tell the difference?
Look, I guess as a computational linguist and a natural language processing researcher, my area of expertise will only go so far. And there's always a danger in crystal ball gazing. I think for all the reasons that we've outlined in the slides so far, that a fully automated system is complex in so many ways. Denise kind of hinted at some of the complexities there as well. The experience, the effectiveness of learning. These are aspects of the problem that go beyond, much more beyond just detecting or correcting even grammatical errors. Think about what the tutor has to do. They have to choose what's appropriate at that particular time to help the student, and choose how best to wrap that message up to give to the student. And that's a really complex task. And I think we're only scratching the surface now in terms of productivity tools, going that whole way of delivering a service where as the people who run the service, you can trust it to, you know exactly what the AI is doing, so that there is some accountability for the way the message is given to the student. I think that whole path is one that takes us quite far into the future, much too far for me to foresee with any certainty. And that's why I believe the right area to look at now is productivity tools. And that's why I think some of the other researchers in the field think that as interesting as conversational agents are these days, it's not yet the time perhaps to think about a conversational agent that does the whole job of being the writing feedback tutor. That's certainly, in my view, not something that we can do right now.
Thank you, Stephen. The only thing I would add to that is a lot of our students tell us that they love our services because it's human, but there's anonymity there as well. And so it's less stressful for them to get in touch. Related to the last questions, has anyone studied the impact on learning of cognitive dissonance that might occur when a student uses an automated tool like Grammarly and gets a response from the machine that it's incorrect or doesn't make sense? How much does this impede the student's trust and therefore their learning?
That's a really great question. I don't have the exact answer to that on hand, but I think looking at these issues will be, I think, should be part of the user-centered design when you think about the way the results from the automation is wrapped up for the tutor. Thinking about cognitive dissonance should be part of that. And in fact, in the some of my colleagues that I mentioned that I showed on the first slide, some of their backgrounds, some of the colleagues have a background rather in psychology and education. So it's important to think about talking with all the related disciplines. There are many disciplines that could have input into the design of such a tool to consider issues such as this. And I think we certainly don't want to lose sight of questions like that. Fantastic.
Well, I will draw this session to a close then. thanks again to Stephen, to all of our attendees today. I hope you enjoyed this as much as I did, and we hope to see you again at future online sessions.
Thank you.
Thank you.